Welcome to 313, Analyzing Processes. This is the first half. We're going to go through step 15. Our goal is to understand how to analyze those processes in Linux. We did it in Unit 1. We were looking at Windows processes. You look through that like task manager thing. Was it like the shell command, PowerShell? I don't remember what it was. I think it was like back here in 1, 2, 3, where we did process management. So we are back in 313. We're going to do this through Linux. Failed to load notation. That doesn't sound good. So let's begin. So how do you manage processes? It's Linux-based systems. It's similar. I mean, there's stuff running in the background. And so a lot of this is going to be familiar. It's just we have a lot of, remember in Linux, it's just kind of like text-based, at least in this operating system. So we're going to have to learn the commands to open that up. A little bit different. So we launch the lab. A reminder that we go our login machine and we have to do the virtual lab. And you get in through opening up connections and opening up alpha. So this is my Linux machine right here. I'm not going to full screen that. That's a little bit too much. So, but I'm going to make it a little bit bigger. Okay. So there we go. Man, I should just do side by side since it's so small, huh? See if I can do that. I'm going to pause. All right, I'm not going to mess around with it, but here's our Linux machine right here. So what we have to do, oh geez. All right, so you opened up this. Let's try this first command. It's going to be the PS command. The PS command lists your currently running processes, so type PS into the terminal. And this is going to get you two processes right here. The first one, this 3114, it says bash, and this other one says PS. So, and here's another representation of that. What is this kind of stuff? So what are both, these are the two processes running. PS is the command you just did. So that's that one showing up. Bash is actually, so bash is a type of shell. And what is a shell? It's like the program that you interact with. So this window, this thing, this is the shell. So this is the thing running, and PS is the command you just ran. So when you run your command, it lists your currently running processes, right? All right. It's everything that you are running as me alpha right here. And if you want a little video, a little representation of what this looks like, you have this user right here, and then you send like a command like ping or whatever to the shell, or you say PS. And then the shell says, oh, let's go to the operating system behind the scenes and say, run this command. And the operating system says, okay, I'll run this command. I'm going to add it to this process table, the list of things that are running on my computer. So that's kind of the workflow of what's really going on behind the scenes. I'm going to add this to our list. Now for me, I got this ongoing list of commands right here. So I've added it already to 313, this PS command. I do a little screenshot. I write in my words. It lists the currently running processes, only the ones that I spawned by default. When I mean just you type PS, it'll be just the ones you spawn. Now, another thing to understand is maybe you want to see what else you can do with the PS command or any commands here, right? Remember we had all those flags, the dash L's or dash R's from last time we were talking about permissions. Well, how do we get a list of everything? We can use the man command. It stands for manual. Kind of like the help me file or whatever. So if I type man PS, I'm getting everything about what PS does. What is it? PS, report a snapshot of the current processes. That's what it does. And then descriptions, some deeper stuff on here. The commands to go through this, I think we did this. I don't know if we did that kind of stuff. Hit spacebar to scroll down. Hit enter, you can go down like one line at a time. That might take a long time. You get spacebar to go down, B to back. You want to like search for a certain phrase in there, a certain keyword. You do the backslash and then the phrase. And there's help and Q to quit out of this. So if I go Q, I quit out of it. If I want to do that command again, man PS. Again, I hit space, like one page at a time. I can go back one page at a time. Enter for one line. H for help. I don't know what help does. I guess help tells me, oh, All of these. Okay. I'm gonna quit. I do. Oh, E. Oh, so help. H for help will tell you all these like keyboard commands, and you want to go forward one line or back. E and Y also work. Well, that's cool. So this is something you get more familiar with Linux based operating systems. You're probably going to be using this more to look up things, and you get you get more used to this kind of stuff. So we're going to add it to my list of stuff right here, and manual. I put all those little helpful tips in there. All right. So add that to your list of commands that you might need to reference later or manual. You can manual any command there. So if like you want to go back and go cd, did man cd. Oh, there's no entry for cd. Okay. So what other programs ran last time? We have make dir, make directory, right? There's all that stuff. So man gives you kind of like the readme file, the help file. In your shell, enter the PS commands you recorded using the scroll bar to view the output. Okay, so we already did that. Now here's a tip. They said PS-EF. So remember the flags? So E, it's like a -E and -F flag. It's the common use of the PS command. It shows every process in a full format listing. So E, I think probably for every process, not just the ones you own. And F means full format, like all the details. Instead of only processes you spawned in abbreviated format. So I did add this to my commands table, ps.ef. And I'm going to say also with full details. I'm guessing. So maybe you want to see what other processes are running. I think on like the Windows machines, it just showed every process by default. So you have to do some extra flags on there to make it work, to make it show everything in Linux. All right, so that's cool. Write that down, but we're actually going to use it right after this. Oh, guess what? We have another command just to throw at you, the more command. So you know how like man lists everything, or it gives you that like README file? And then we had, okay, so that tells you every command you can do, right? We also had something called like cat from last time, and cat would just like print everything in that file. More command kind of feels like cat in a way, but it's a little different. The more command lets you control output with the keyboard instead of having to find it's a different way of doing output. All right. So, in fact, I'm going to man the more command. File perusal filter for CRT viewing. So it's a way to like view everything or read. Like maybe like if there's a big file you want to read, but there's a lot of stuff in there. If you say print it all at once, it's just this huge thing you're gonna have to scroll up and down, and you don't want to mess with that. So more will let you kind of control this better. So so let's say I do more / etc. protocol. It's going to open up this protocols file. We go more / etc / protocols. You open this up. So notice here it says, oh, there's more stuff I've done. Only got 63% of this. This is like a list of protocols you can use. The idea is that instead of going cat etc protocols, wait, go etc protocols. So if I did cat, it just prints it all out at once. And like you have to scroll back up to go how far. Like there's no real indication of how far I had to scroll back up. And notice it's kind of like, well, how far is it? There's so much stuff on my screen. So, and it was like a screen and a half's worth of stuff. That might be, especially like if I had a smaller terminal, I wasn't going as full screen. It's just going to be harder to scroll back up and search for everything. So the more command, instead of cat, will let me control what I see every time. Like, and I can do those same commands that I did with manual, like enter, do one line at a time, space bar to do big jumps if I want. And there we go. So it's another way to like print out what's on the file, but to kind of control it a little better. All right. That's the point of more. So I wrote that down in here. Similar to cat, you control how much is printed. Seems weird. Why are we using cat? Why weren't we just learning more at the start? So when you more a file such as protocols, it displays a screen full of data that waits for a command. That's what we're doing here. Command is the same as the ones that you use to manipulate man. So same commands. We use that to view another file. Okay, so we can learn protocols. I can use that to view services. So what if I went to services? And I can see all the services. Notice there, this is only 4%. So this is a much bigger. Maybe I want to browse this. This is like page up, page down right here. This is a lot easier to browse than if I did that all at once. Like, look how much stuff this is. If I made that print out all at once, I'd be scrolling back up, and I don't want to deal with that. Too much stuff. So that's why more is helpful. Now, more doesn't work for everything. But more, if I do more ps-ef right here in step 9. What if I did this? What's going to happen? -ps, no, more ps-ef. It says no such file or directory. Like, what? Why didn't that work? If I did cat ps-ef, that work? Wants to explore. So it doesn't work because more will only print out like what's in a file. Like, same thing with cat. You can't more just some command right here. It's not like manual. So you do the man. If I did that, well, that would just do everything for PS. So that'll give you like the manual for that command, PS, but you can't just more. You have to use like an actual file. But there's a way to kind of hack it. So you need a different mechanism. You can use the more command because maybe you want to like read everything. Like PS is going to print out every command here. So if I just do ps-ef, this is every process running on the machine, not just my own. There's a lot more, and I have to scroll up and down, right? But maybe I want to have the neat functionality of the more command where I kind of control it better. So the way you have to format it is like this, using this pipe. The pipe says like, hey, run this, but instead of just printing out everything to the screen, the pipe says your output should go to the next thing. So PS, and then it says, oh, put this in a more command. It's kind of weird, but the pipe commands are used sometimes like, let's say you don't want to print out to a screen. I want to like save everything to a file. I can use this pipe command to say, hey, just change this output instead of my screen, give it to the next program or give it to the next file. So it's a way to use multiple things at once and to like make sure that the results from one thing get passed on to the another thing. So it's kind of neat what pipes can do, but it's a different thing. Like, you're not really doing this in Windows. So if I did PSEF, do this pipe with a more, now I can see this, but there's the more command, and I can control going through this. A little bit more control right there. A little bit more control. So again, that's more right there. So it's kind of neat. Maybe we end up, I don't know, more was kind of the weirdest thing for me today. So I don't know. Let's try the next thing. I think I kind of understand more now, and I've added it to this list, but you might have to use this. I mean, that's just a way to print things out and kind of control it a little bit more. All right, so let's look a little more in depth. So, we did this this command, right? Processes.ef. Now, you might see a few different things going on here. If I can go full screen. And I can, because might as well use that. So you see a few things here, and at least, especially at the start, we had this UID, PPID, PID, PPID, etc. So what do all these columns mean? And if you remember what we did in Unit 1, maybe it's very similar. We had to do this before. So user ID, this represents like the ID of the user that started this process. So you are logged in as alpha. If it's a process that you created, it'll say alpha in here, like it says for these commands, alpha. Now, root is a kind of a special user. It's the root user. It's kind of like the original user, kind of like a default. It's not even a default user. Like no one logs. Like that's just like a kind of an internal user account that controls everything. The root account. All that. Now we have PID, which is your process ID. So every process running has a unique ID number. And then you have a parent process ID. So this will tell you like some processes spawn other processes. And this was something that we looked at when, if you remember in unit 1, we're trying to look at what was potentially hacked or what, and you looked at what are like bad processes running around. So you can't just like kill one process. You have to figure out like which process created that. Maybe a legitimate looking program created was the parent that made some like bad programs. So you want like maybe you downloaded, I downloaded a new game for my computer to play video poker on my computer. And that seemed like a legitimate process, but when that runs, something else it also spawns some other bad program. This helps you get to figure out which programs were created by what. So notice process IDs 1, 2, 3, etc. The parents. So processes 3 through 9 have a parent of 2. So this process created everything else in here. And then this 2 process was created by process 0. It's not on here, but I think that just means it doesn't have I'm guessing that means it doesn't have a parent. It's like an original process. That's probably what that means. A value of 0 means the process was started as one of the first processes in boot time. Okay. And then CMD is the process or the name of whatever's running, the command. So program's being running. All right, you can instruct the more command to search for a string such as username. So let's say when I run the more command. So I'm going to do the process thing again. Show the processes again, and then we're going to search for alpha. So I know we kind of already did this just by scrolling. I want to show you what it looks like. You can do it's like backslash, and then we go alpha. This will help us like kind of filter. And so only things that are have the word alpha in there will be shown. So you can see right here, I have these 4 processes that I have created in my alpha account. And then there's this root process, but it's doing something related to alpha. So that's why this is showing up as well. Not just things that have that username. It could be alphas in the name of this process. All right. And so there you go. Now you see all the information related to me. And it should happen really quick. And then we can answer some of these questions. So what is the process ID of my .bash? If you look at my .bash right here, I can just look at it up here. Oh no, I'm going to look at mine. My dash bash right here has a process ID. That's the first column of 3114. I don't know if it's the same for everyone. It might be different for you. You might have a different process list depending on what you've done so far. Yeah, I think it is different because I think last class I had a different. So these might not be the same numbers for you. That's okay. But look at your .bash and then look at this number. And so my process ID is 3114. Okay. What is the parent process ID of the .bash process? The parent process would be 3113. So its parent is this one right above. What is the command that spawned your bash process? So this one above spawned it. And the command was this sshd alpha. I don't know what that is. Well, so they kind of walk you through this. And this is one thing to understand as we do these things, because we're using a virtual machine to teach you this lesson. There's going to be some weird processes that are running that are just PLTW. And this SSHD is PLTW. So really, we ran this bash thing that was created with this virtual machine, but these are just because we are using a virtual machine. If this was in real life and you're at your terminal at work, you're not going to see those kind of things. Okay, just understand that for now, that they were created by PLTW. So we're going to add that more command. Added it to my list here. So again, for your assignments for my class, just add the same commands, but write this in a way that you'll understand. Maybe make some screenshots or do it in a notebook. That's what I'm looking for. All right. We want to monitor the process ownership. Monitor ownership. In an earlier lesson, you learned that knowing the process, that was back in Unit 1, of an operating system helps cybersecurity specialists find malware. Yeah. If know the process, like knowing which processes are good processes and which ones are potentially sketchy, right? Because there's a lot of random stuff running in the background that you're like, I don't know what that is, but it's okay. Supposed to run. Important part of securing Linux is knowing which stuff is good, which stuff is like the system has to have on. So we're gonna create a list of good processes, and you're gonna probably have to use this for next project. And I'm gonna write it in my commands list. So if you launch a command when you're logged in as alpha, alpha owns the process. Suppose you want to monitor all processes related to other users that are logged in the system. You don't want to watch one user's process. You want to watch everyone's. So one thing you could do, we did that EF to show them all, but they're all like in a big list. I want to sort that list by user ID. So what I can do, and I added this into the PS commands. If you type this command, ps-sff, and then / sort user ID, this will sort it. It'll print every process again by every user, but it's going to sort it by user ID, so it's not all chunked up. Because like this was how it was in the past, and like root, but then like statted, like the roots are all mixed up, so it's not really sorted very well. So it's hard to like see. It'll be hard to look at. So what we're going to do is we're going to sort this. So I'm going to go type that command in. ES-EF / sort ID. Yep. We type that. Now all those commands are sorted by user ID. So all the roots are first. Yeah, I probably should have done a more, right? Could have piped in a more. You see all the roots first? Okay. And then more roots. Because like root is stuff that is created by like the main user, whatever. And then we got this user daemon and www data and then 101 and then stat D and 103 and MySQL. This isn't a user. This was just wrap around from the line above. And then alpha. And then you're looking at this and like going, a user ID 101 and 103. Where's 102? Like, is that legit or not? Like, I don't know. I'm new to this, right? You're new to this. Like, I'm thinking like, do I know? I don't know. But we're going to say all of these users like are going to be legit right here. So these are all like stuff that opens up users for your operating system. However, like the boot up works, these are all legit users. Some of these might be Project Lead the Way virtual machine ones too. I'm not sure. Other than you, Alpha, what other users have on the list? In the space after your commands, record the users you see. These are all authorized system users. So we're going to say that all these people on here are good. If you see stuff that these users do, that's good, right? If you saw some other random user on here, like some user could have been named 105, that would go, hey, that's not on my good people list. So actually on my list, wrote down every name on here. That's good. And alpha as yourself, as you can say, is good. Now, what if those users get hacked, or can a hacker pretend to be root and stuff? I bet we get into that later. And yeah, I'm sure they can. But for right now, we're going to say, hey, these are the legit ones. This is one way to tell if things aren't good, if it's some user on here that is unknown or that is not one that we normally trust. Other than your own process, all the processes you currently see in the output were spawned at boot time. So So when you started it up, they respond. Sysadmins, security analyst determined systems config. This is one that said MySQLD is started at boot time. The MySQL. And if you remember MySQL, remember SQL? We were doing that with websites, databases. Provides functionality for SQL commands. These are the same SQL queries you encountered in Unit 2. Assume the system is properly configured. You might be like, well, why would you have SQL commands? Well, maybe you have like a website being hosted on here, or some web interface, or some other kind of database. So that's why. I mean, their answers are, assume maybe there's some website or database. Okay, cool. So that's what's going on here. There's a few different commands. And yeah, hopefully you wrote those down, your Linux things. Play around with this. At this point, folks, because I didn't get as far in the other classes, we got off topic. Mr. Lamonaco came in too, and I got distracted. And then we had a lot of off-topic conversations because apparently there's game night on Friday. Oh, this is in the video. Well, folks, in the video, we're done.